So up to this point in our exploration of linear equations, we've worked with the standard form of a line, which, as we recall, or maybe I'm trying to get a pen here, hold on. As we recall, is what we've done thus far is the standard form, which is ax plus by equals c, right? And which is a pretty easy thing to find the x, y intercepts for, which makes it kind of easy to graph, and sometimes it's a good way to represent things. But this other form of a line, the slope-intercept form of a line, is way, way better because for a lot of reasons, some that we're going to talk about here and then some we're going to talk about later on as we proceed in this unit. This isn't going to take very long to talk about. A lot of us come into this course knowing about the slope-intercept form of a line. We just maybe don't know that it's called that. So basically, if you've got a linear equation that is written in the form y equals mx plus b, where m is the slope of the line and b is the y-intercept, it's in slope-intercept form, right? Basically, another easy way to look at it is if you've got a linear equation, meaning you don't have any exponents other than 1 for the variables, and you've got y by itself, that's in slope-intercept form. So what the important thing besides the exponents being 1 is y by itself on one side of the equal sign. And if it's written in this form here, y equals mx plus b, you can very easily pull information out that's kind of important stuff to have for a lot of the situations that we'd be using it for. So let's take a look at this table here. We've got 3 different equations written in slope-intercept form. And in this first one here, if I wanted to find the slope, I've got y by myself. I don't have any exponents on the variables other than 1. So whatever the coefficient of the x is, whatever's being multiplied by x is my slope. So in this case, the slope is 4. And just as a reminder, that's the same as 4 over 1. We didn't really talk about that much when we talked about slope, but anytime you've got a whole number, you can write it as a fraction over 1. Right? And the coefficient of our x, what's being multiplied by x, is our slope. What's being added or subtracted? That's our y-intercept. That's our b. I don't know why they pick m and b for those variables. It doesn't make any sense to me either. But the y-intercept is what's off by itself, which in this case is positive 7. So the y-intercept is 7, or as we remember with y-intercepts, it's where the x is equal to 0. So it's technically 0, 7. We go down to the next one. I see an x and I see something being multiplied by the x. Please don't make this mistake. Don't say that 3 is the slope and 4 is the y-intercept. The slope of that line with this equation here is 3 over 4. It's 3/4. That's it. It's whatever's being multiplied by the x. Not necessarily a whole number. It could be a fraction. Is going to be our slope. So our slope in that one there, that second one, is 3/4, 3/4. The y-intercept, well, you could look at it and say, well, it's not there. Well, we could write it like this. We would never write it like that because that doesn't make any sense. Why add 0? That doesn't change anything. And you could see, however, that the y-intercept is 0, or it goes through the origin at 0, 0. And so just because it isn't written in y equals mx plus b, but it could be, that counts as well. And then this last one here, again, you're missing the x. There's no x in this one. So really, we could write this one as, I'll write it below it, y is equal to 0x minus 3. These two are equivalent. These two are the same thing, same value, right? But the reason we don't have an x is because its slope was 0, and when we multiplied it by 0, the x disappeared, right? That's what makes it an equation with no x variable. And the y-intercept is -3 or 0, -3. So again, really easy to determine the slope of the y-intercept without doing any math. You're just kind of looking at it and saying, All right, well, the slope had a good breakup. It hangs out with its x. Whatever's hanging out by the x, that's your slope. Whatever's off by itself is going to be the y-intercept. Another thing that this is another reason the slope-intercept form is so so handy is it's really easy to determine an equation for a line just by looking at it, right? Take this one here on the coordinate plane there, and we want to be able to determine the m and the b, right? Well, the b is the b is easy enough to determine. It's going through the y-intercept at +2, so the y-intercept at 0, 2, right? And what's the slope? Well, slope is rise over run, so I'm going to go from this point here because I've determined that goes through that's an easy point to determine, and this one here, I think we've used this one before. The line's going downhill, so I know my slope is going to be negative. I start by going down 2 and then over 3, so my slope is negative 2/3. I have everything now to make an equation for that line. Y equals negative 2/3, that is a negative sign right there. I'll straighten it out a little, I guess. Negative 2/3 x plus 2. That's the equation for that line. Rather than take take a bunch of points that are on that line and calculate the slope and then figure it out, just look at it and say, okay, well, I can figure out that slope. So if it's on the coordinate plane and you have the points that are easily determined, it's very easy to get an equation for a line in slope-intercept form just by determining the slope and the y-intercept, neither of which require a great deal of calculations. And then this is the last thing that we're going to talk about is when you are graphing a line that is in slope-intercept form, it is equally easy to do that in the occasion that you had to graph it by hand. We are going to be using some either graphing calculators or Google, the Desmos calculator, whatever it might be, to do this, but it's pretty easy to do by hand. So we want to graph y equals negative 3x plus 2 on the coordinate plane over here. So we're actually going to start with the y-intercept. We're going to plot the y-intercept. Okay, it's going to hit the y-intercept at +2. We're going to put a point right there, right? So we've accounted for that. We've accounted for the y-intercept. Now we have to look at the slope, right? We're going to move according to the slope to get our next point. Now, as we said in the first slide, when you have a whole number slope like we have here, you could write it as -3/1, right? That'll be the same thing. That way you can see it as a rise and a run. Sometimes you miss it if you don't. I've seen people miss it if they only have the whole number. So from that point, and that's important, don't start this from the origin if the y-intercept is somewhere else. Start from the y-intercept and then go down 3 because my rise is -3, 1, 2, 3, and then over 1, and plot a point. And just because it does, you could draw a line through there. I'm not going to try to do that because I want to make sure I have at least 3 points to do this, which is the last step. So from this new point, move according to the slope again. 1, 2, 3 down, 1 over. If you can do it a 4th time, 1, 2, 3, to get 4 points, even better. Because if you only do it twice, my advice is if you only do it twice and you make a mistake, you'll still be able to make a line through those 2 points, even though one of them's wrong. Right? And then if we make a line now through this, that line there is our line of the graph. So the slope-intercept form of the line is really handy because it's very easy to determine some important numbers from that equation without a lot of math. It makes creating the equation from the graph really easy, and it makes graphing the line from the equation just as easy. We're going to expand on this, obviously, but this is our first first pass at introducing some of these ideas. We're going to go over plenty of these in class, Please let me know if you have any questions. I hope this helped.